So we have Jimmy Neutron here.
Okay, hello. In today's experiment, the objective was to create a steamboat. Using the second law of thermodynamics, which states that a body which has high energy and it's in contact with another body with a lower energy will transmit its energy till an equilibrium is achieved.
So what we did was to create a boat. The base was made from a gallon of milk. Then we had our source, which was the alcohol. The alcohol then heated this can, which is filled with water, and when it was heated, the steam that it produced came out from this little hole, and that moved this windmill. And with the help of the axis, it moved this big gear, and the big gear moved the little gear, which meant the velocity was going to be faster, and that little gear would move the turbine, which will create a thrust on the boat.
So then, to find the heat, we use this equation, which is heat equals mass times latent heat vaporization. Therefore, we need to find these variables. So to find mass, we use mass equals density times volume, where the density of water is 0.997 grams over centimeters cubed, and the volume we use a syringe to find that the volume of water used for the boat was 70 centimeters cubed. And by substituting these values, we found that mass was 69.79 grams, and the latent heat vaporization we found it from a chart that you gave us, and we found that the latent heat was 539 calories over grams. And then by substituting that, we found that heat was 37.616 kilocalories.
So then we did the work, which is equal to pressure times the change in volume, which is also equal to the N times R times the change in temperature. In order to get the N, we use the equation, which is mass over molar mass of the water, and then the R, which is a constant, and the change in temperature, which we assume that 94 it's the boiling point, the boiling temperature in Mexico City, and the 15 is the average room temperature in Mexico City as well. So then we change those to Kelvin and use the other values, and we get the work in joules. And in order to get the efficiency, it was work over heat, and it has to be less than 1. And we had the value in joules, so therefore we changed them to calories, since we had that heat was in calories. So we got this value, which is really small, therefore the prototype of the boat that we designed is not that efficient. It's not efficient at all.
Since it was not that efficient, the objective of the experiment was partially achieved, because we were able to build the steamboat, which worked, but since it wasn't efficient at all, since it was barely moving, it didn't work. This could have been because a lot of heat was lost. For example, when the steam came out of the can, it could have gone in many directions instead of one. So it didn't go directly to the windmill, so not a lot of force was produced, and since there were a lot of frictions between the axes, therefore the work was almost none. So because of that, we made a second boat, which actually worked. Nevertheless, as we can see, this relates with the second law of thermodynamics, because the heat of the candle or the alcohol was transmitted into the can with water, and that water started boiling, and since it was a non-ending heat source, it just got hotter and hotter until it started boiling and it started getting out of the can.